Patrick here. Today we're going to talk about fractions. Now, fractions strike fear into the hearts of a lot of very competent people. There's something about counting by less than one that really throws people off. So we're going to talk about how fractions appear on the SAT and how they sort of make normal questions a bit scarier. Now, there are two things to think about when you're dealing with fractions. First is sort of just basic operations. How do you manipulate fractions? How do you add them, subtract them, multiply, divide, those types of things. Now, we're not going to talk about that because there are a ton of really good resources on the web that tackle basic manipulation of fractions. So go to Purple Math, go to Khan Academy. Links are underneath if you need them, but we're not going to talk about basic operations. What we are going to talk about is how fractions tend to muck up SAT questions and some strategies for getting around those. So we're going to look at a few sample questions. We're going to look at some strategies for getting more comfortable with fractions, but like I said, we're not going to talk about how to add and subtract fractions. That's covered elsewhere better. All right, so let's get started. So let's look at number 10. So the construction manager has 90 hours budgeted for projects A, B, and C. If 1/3 of his time is used for project A and 3/4 of the remaining time is used for project B, how many hours does he have left for project C, right? So we have 1/3 of his time. Now remember, of always stands for multiplication when you're talking about translating English to algebra. So 1/3 of his time. So 1/3 of 90 hours. So 1/3 times 90. So that is 30 hours. And again, we're going to work neat so we can keep track of everything. So we have 90 hours for job A, right? Just 3/4 of the remaining time, right? So there are 60 hours remaining, and it's going to be times 3/4, right? Again, of. So 60 times 3/4 is 45. It's 45 hours, and that's for job B, right? Project B, and it says how many hours does he have left for project C? Well, he used 30 and 45. That means he has used 75 hours, which means that of the 90 he started with, he used 75. That means 15 hours remaining, and that's for project C, and that's the answer, 15. Okay, so remember with translating English to algebra, of stands for multiplication. Just remember, when you give you a fraction, it's always of something, right? It's a fraction of something, unless it's the fraction itself is the number, like 1/4 of a cup, right? In this case, the quarter is the actual quantity, but usually it's a fraction of something, right? Okay, so let's look at number 11. We have 2 over x equals 200, and they want to know what x plus 1 over x is, right? Your calculator is probably going to be your friend here, and the biggest sort of reason for that is if you look at the answer choices, they all have decimals in them. So going from decimals to fractions looks like we might want to use our calculators. But let's get started. So first of all, we have 2 over x equals 200. And an easy way to visualize a question like this is just to put the 200 over 1 and treat it like a proportion. That is, you can cross multiply and solve for x pretty quickly then, right? So 2 times 1 is 2 equals 200. X therefore equals 2 over 200. Now you can use your calculator here, and that's not a problem, right? Or you could just keep it as a fraction. So you can reduce this to 1 over 100, right? And that equals x. So they're looking for 1 over 100, which is x, plus 1 over 100, right? Now, 1 over 100 is a complex fraction, which again is scary for a lot of students. There you go. So just remember that this big division bar means this numerator divided by this denominator, right? When you're dividing by a fraction, you're really multiplying by the reciprocal. So you can rewrite this quantity as 1 times the reciprocal of the fraction that's in the denominator, so 100 over 1, right? Which is 1 times 100 is 100, right? So the total sort of the representation here is 1 over 100, which is x plus 100, right? So it's 100 plus 100th, right? Which is a. So we didn't quite need the calculator for that if you're comfortable enough with the fractions, right? Let's try another fraction question. Okay. And this one I chose to include because it's really useful to have a picture sometimes. So 15 says a container is 2/3 full of water. If 4 gallons of water were removed from the container, it would be 1/2 full. how many gallons of water does this container hold when it is completely full? So we included a picture to get you started. So here is the container 2/3 full, right? So this is the entire container. It's at the 2/3 mark, right? Now again, think back to what I said before. It's 2/3 of something, right? So it's 2/3 of the entire quantity, right? And that's what it's asking, right? How much is the whole when it's completely full? So this whole quantity is unknown. So we're gonna call that EX, right? But this quantity that's in here right now is 2/3 of the full amount, right? So this quantity in here is 2/3 X. That's a really important thing to remember, because it says if 4 gallons of the water were removed from the container, it would be 1/2 full. Right? So we can translate that into an algebraic expression now, right? We can say if 4 gallons were removed from this, right? So 2/3 X minus 4 gallons, right? And it says it will be 1/2 full. And again, it's 1/2 of the entire quantity, so 1/2 X. And now we can solve for X, right? So let's get this over here so we can do it in one step. So we're going to subtract 2/3 from both sides. And you say, but Patrick, that's going to give us a negative number. It's okay because we have a -4 over here. So -4 equals, now remember you want to get the bases the same. So 1/2 X is the same as 3/6 X, and then 2/3 X is the same as 4/6 X, right? It's a 4 right there, sorry. So 3/6 minus 4/6 is 1/6, right? -1/6 equals -4. The negatives drop out, right? Both sides. And then we have to solve for X, right? So we can multiply both sides by 6, aka dividing by 1/6. And that's X equals 24. That's the answer. Okay, makes sense? All right, good. So remember, with fractions, it's almost always a fraction of something. So if you have something that represents the total quantity, then your math is going to be a lot easier. In this case, we chose to represent the entire volume as X, and then made everything else a fraction of that. All right, so there you have it. There are ETS's, some of their favorite ways of testing fractions.